So right now I'm taking this text from Wikipedia and I just copied it over. I already ran it through and removed all spaces and any other characters. So we're going to take this and we're going to run the Enigma program. So I'm going to set this to the rotors as 413, and then I'm going to set it as DGW. So I'll do encrypt from file, and this will encrypt the file using the Enigma process. So it gives me this. It's all jumbled up. It should look like random letters. So I'm going to move that into the in folder so that we can decrypt it just to test it out. So I'll set up the controls again and we'll encrypt it again. In the Enigma, encrypting and decrypting are the same. So if we encrypt decrypted text, it should give us the plain text back, which we see. So we'll use this encrypted text with these settings 413 DGW, and we will try to break it. So this is going to try to break it. It's trying every combination of, there's 5 different rotors, and for each rotor, it can have a starting position. Now there is also a ring position as well as a plug board that I do not have implemented right now, but that would happen after this is happening. This technique would still work. It would just take an additional breaking of a Caesar cipher, basically, which is easy to break. So this right here, this footage is being sped up 8 times. Sorry, 16 times. It's being sped up 16 times. It took quite a while with the technique, even with a whole bunch of compiler optimization and optimization of the code that I'm doing. So you'll see it tries every combination, and then it uses what's called the index of coincidence. And that basically measures letter frequencies to try to match English's natural letter frequency. So we see it picks this one as the best, and it automatically decrypts it for us. And we see we get the original plain text back, as well as the settings. 302 is the same as 413